So what you guys are going to be doing today is kind of going through this packet. It's just practice problems over probability, and just to get more practice on it and to kind of get used to solving different types of problems, okay? Now there's all different types in here, from like normal probability to like where you have two things that are happening, so you have to multiply, to sample space. Like there's a lot, okay? So what I'm going to do now is I'm going to go through the packet. I'm going to kind of give you hints on a couple of them, maybe solve a few of them. And then the rest is going to be up to you, okay? This is due at the end of class. The sub is going to pick it up, so make sure you have it done, okay? So with number one, you don't actually have to come up with a probability. All you have to do is tell me all the possible combinations, okay? So out of all of these, which one gives you all the possible combinations? Do not just look for the biggest one. All right, it's not always the biggest. Make sure you look and see like what it's telling you, what things go together. Make sure it does all of them, okay? So that's that. For number two, let's look at this. So we have this teacher who's grading some math tests from 50 students, and so this is his results. And so it says, based only on the information in the table, what is the probability that the next test he grades will be an A or a B? So a couple things that's important information. If it says based on the information, okay, or based on the table, you're only going to use this. You're not going to use what you know or what you think. You're only going to use what they gave you, the information they gave you, okay? Now, we are looking to solve this problem. We are looking for A or B. So if you remember, OR stands for what? Pause the video. See if you can figure out what OR stands for. Pause the video. All right, so OR means we're going to add. So we're going to take whatever A is and add it to whatever B is. So we're going to go over here, and we have A and B. So we said OR means add, so we're going to add them. 5 and 4 gives me 20. Now, remember, when we do probability, we do what we want over the total. Okay? So, what we want is 20. The total, well, we got to figure out everything. So, we're going to add over here. 15 plus 5 gives me 20. Plus 3 gives me 23. And then plus 2 gives me 25. Plus 0 is just plus 0. So my probability is 20 over 25. But this 20 over 25 is not here. So you have to simplify it. Now, I'm not going to simplify it for you. I need you to figure that out. Remember that if you have issues dividing and you can't see which one it is, try the number 2, 3, or 5. Okay? See if it can be one of those. All right? So you guys go ahead and finish that one. Over here for number 4, we have this guy who has this dice. It's an 8-sided dice, okay? It's not a normal one, and it's numbered 1 through 8, okay? So instead of like 1 through 6, this one's 1 through 8. So it wants to know the theoretical probability that he is going to get a heads or a 2. So theoretical means like ideally, like regardless of how many times you do it, what do you think the probability, or what is the ideal probability? Okay, so it's just regular probability based on what's given. So we want heads and a 2. Now, heads on a coin is just a half. And then a 2 on this dice, well, there's only 1 2, okay? Out of a total of 8. All right, so that's number 2. Okay, so 1/2 and 1/8. But we want an and means 2. See if you can figure it out. Multiply, so I'm going to multiply them. All right, I am not going to multiply for you, so go ahead and do it and see if you can find your answer. Make sure to simplify if necessary. Okay, all right, so we're done with that one. Let's go to 6. So for 6, there's some customers at a restaurant, and then this is the table to show their favorite flavors during a day. So it says, using the information in the table, what is the probability that a randomly selected customer will order lemon lime? So Based on the table, that means based on this. Well, what is the probability of lemon lime? Remember, probability is what you want over everything, okay? Or total. So, how many lemon lime sodas are there? And then how much is everything? Then make that into a probability and then go ahead and solve. Okay? I am going to do number 7 though. A manager knows that a restaurant sells an average of 960 sodas each week. Using that information and the information in the table, how many cherry flavored sodas is expected? So, couple things. It says, one, we're going to use the information as the guide, okay? Now, but what we want is we want to know how many cherry flavored sodas can she expect to sell, okay? So, first thing we have to do, whenever we expect something or predict something, we have to find the original probability. So we want cherry flavored. So we're going to go up here. Well, there's 12 cherry. So I'm going to do 12 over the total of everything. So I'm going to come out here and add them. So we have 24 and 28. Okay, 4 and 8. We got 12 and then 5. Then we're going to add 16. 8, 6. And then we're going to add 12. 0 and then 8. So 80. So my total is 80. Now she knows that they sell an average of this many each week. Okay? Now again, when we set a probability, we want 1 over everything. So is 960 how many you want to sell, or is 960 everything that you sell? Like the total of everything you sell. See if you can figure that out. Pause the video if you have to see if you can figure it out. So hopefully you paused it and figured it out. But 960 is going to be your total. It's going to be your everything. So because it's your everything, it goes on the bottom. And we want to know how much she is expected to sell. How much does she want to sell? So that is your part or your X. Well, we know that these two things need to be equal to each other. So now we're going to do our proportion. So we're going to cross multiply and then divide. Okay? Alright, so you guys go ahead and do that. I am not going to do that. Make sure when you're doing these problems, you look and see if there's like a not or something, because that is key information. So make sure you are reading. Okay? If you need to text code and highlight and write, do that. Okay? The more you figure out what's key and what's important, the better you are going to be solving the problem. Okay? Let's go to the next one. Alright, 11. So, you can do 10. Let's do 11. 11 says Loretta wrote a letter of the letters of her name. And so she shuffled them, turned the cards upside down, and she chose 2 cards one at a time. What is the probability that she chooses an O and then a T? So, some key things. She chooses 2 cards one at a time. So she's going to take one, look at it, keep it, and then choose another one. Okay? So this is without replacement. Meaning she does not put it back. Okay? Does not. So we want the probability of doing an O first and then a T second. And we have an and. So, figure out what we want. So if you can set it up, I want you to go ahead and set it up. Pause the video, see if you can set it up, and then unpause it and check it with mine. So pause the video. Alright, so we want an O, and then we want a T. The probability of getting an O, see if you can figure that out. Pause the video and see. So O, hopefully you paused it. But an O, there's 1 O out of a total of 1, 2, 3, 4, 5, 6, 7. So 1 out of 7. Now we have to do T, so pause the video, see if you can figure out that probability. Hopefully you paused it, but it is 2, because there's 2 T's out of. Now, out of, if we did not replace it, meaning we did not put it back, the O back when we took it off, how many total cards do I have now? 1, 2, 3, 4, 5, 6. Okay, it changed because she did not put it back. Alright, and now we have this and, which means multiply. So when I multiply that, multiply across, 1 times 2 is 2. 7 times 6 is 42. And so now if we look, my number is not there. Yes, this is a 49 and yes, this is a 42, but just because they are alike, okay, does not mean that we pick that. Oh, hey, that's closest, so I'm going to pick no. See if you can simplify it first, okay? So remember, if you don't know what simplifies, what this simplifies by, try the number 2, 3, and then 5, okay? So we're going to try the number 2. Well, 2 divided by 2 is 1. And then 42 divided by 2, I'm going to come over here and see if I get a whole number. 2 goes into 4 twice. 2 times 2 is 4. Bring down the 2. 2 goes into 2 one time, so 21. So then my answer is C. All right. So next one, for number 12, couple things. I think you can figure this out. Just a couple definitions. An odd number is anything that cannot be divided by 2. So the number 1, 3, 5, 7, 9, 11, on and on and on. A prime number can only be divisible by the number 1 in itself. So it has 2 numbers that it can be divided by, 1 and itself. So these are the numbers 2, 5, 7, on and on and on. Then it'll be 11 next, and then on and on. And then, so for example, like the number 9 can be divided by the number 3, so it cannot be prime. Okay? And then an even number is any number that can be divided by 2. So 2, 4, 6, and 8. Okay? And then on and on. All right. Nicole is randomly selects a red card. And we want to figure out what outcome is the complement. So the word complement just means whatever is not. So if you do not pick up a red card from a deck of cards, what color card or what kind of card did you pick up? Well, the opposite of red is black, so it would be black. Okay, next one. Last month, Greg arrived 3 out of 21 days. So we have to figure out which pair of these is correct. Well, if we know that he was late 3 out of 21, we're going to that's nowhere over here, so we're going to have to simplify. So remember, try the numbers 2, 3, and 5. So I'm going to divide by 3. So I get 1 and 7. Well, these two are the only two with 1 and 7. So now I'm left with another probability. Do you think the probability of it happening is 1 out of 7 and it not happening is 7 out of 8? Or do you think the probability of it happening is 1 out of 7 and it not happening is 6 out of 7? So I want you guys to see if you can figure that one out, okay? 15. Remember that half is a fraction. It's like half. 20%. Remember to change a percent to a fraction. You put it over 100, and then you simplify. Okay? And then these, I think you can do, these are all about expecting, okay? So remember when we expect, we have to do a proportion, sorry. And I think the rest you can figure out. So this page is due before you leave. I don't remember if I said that earlier, but it is due before you leave, so make sure you turn it into the sub. If you're having issues with them, mark it or so that whenever I get back, I can address it. But I do expect you guys to finish this whole thing. Make sure I see your work, especially the ones that you have to multiply and kind of think about it. If you just have answers circled, you are not going to get the credit. So you have to have work. Make sure you understand how to solve each and every problem. Because if you have an answer to something and let's say you got it right, but you can't explain it to me when I get back, I'm going to assume you cheated. So please make sure you know how to do everything. Talk to each other if you're having issues. But this is an independent assignment. All right? So get to work.